Hello everyone, welcome to the course Hydrology EVE 301 offered to civil engineering students during 5th semester. I'm Kirtan Adhikari, faculty at College of Science and Technology, Royal University of Bhutan. Hello students, let's continue our session. So in the previous class, we have discussed about the mean section method and the mid section method to compute the discharge. Here we are going to study about the rating curve. Rating curve is a plot, okay, it's a plot that is drawn between discharge and stage for a particular river section. So this is the river, and if this is the section, so at this section we'll have to, a rating curve is developed. Basically the main function of a rating curve is once you have the stage information recorded, then you can use the rating curve. So this is the stage, so you can use the rating curve to compute the discharge. Okay, so this curve gives the relationship between discharge and stage, because the discharge is a function of stage for a particular section. So if a rating curve is developed at one particular section, let's say for example the Lungthemphu site, then that is applicable for only that location. It is not applicable for any other location. Okay, so the rating curve, what we do is we go to the site, we do numerous discharge measurement at various site, okay, at various water level. So let's say this was our main channel. Okay, so at this level we go there and go to the site and find discharge. So we know the stage and then we calculate discharge. Again, after we do numerous discharge measurements. So at this stage we do the discharge computation, at this stage we do the discharge computation, and at various stages we do discharge computation. Now what we'll have is, if you tabulate the values, we'll have stage on one column and discharge at another column. So from this tabulation we draw the plot, that is the rating curve. Now once we have the plot, then the next stage is we simply have to go to the riverside and measure the stage. So once the stage at unknown stage is recorded, so from there whatever the stage is here, whatever the stage is recorded at the riverside, corresponding discharge value can be computed. So this is a fairly statistical method. Okay, so let's go on studying how exactly this is done. Okay, so as I said here, the sufficient stage data and discharge, corresponding discharge are tabulated. Okay, so you have to have at least okay 20 to 50 readings, so then only you can plot a very good rating curve. Okay, or else the data won't be sufficient. So whatever the graph that you have plotted, whatever the best fit line that you have drawn, that may not be representative for the section. Okay, so this is what I explained here. Okay, what happened now? All right, now what happens is this, the discharge at a particular location. Okay, discharge is a function of so many things. One is of course the stage, right? Another one is the flow area, the hydraulic radius, the roughness coefficient, the slope, right? So discharge is not just dependent upon stage, it is also dependent upon so many other parameters. So what happens is, this rating curve, whatever rating curve we have drawn, it is summarizing all the effect in form of one curve. So it is the summation of all the effects. So although I have said discharge is a function of stage and plotted this diagram, but we need to understand that all this parameter affecting this other variables, independent variables which are affecting the discharge, is also somehow summarized in this curve. Okay, and these factors are what we call by the controls. Now if we compare winter and summer, during summer there would be vegetation growth, right? So if the vegetation growth is more in summer, of course the Manning value would then increase. and correspondingly the depth at that point might increase for the same discharge. So these kind of small things affects discharge computation. So when we draw a rating curve, it is summarizing all of those effects into one form in one line, and those factors which we call it as the controls, these are the controlling, because it will control the discharge. Okay, and if the relationship of constant with respect to time, it is called the permanent control. Now here comes the term permanent control. If our cross section is not changing over the time, so for example, like gauging site at Lung Te Pho, it may not change, okay, compared to the rivers that are there in southern foothills. In southern foothills, it is the rivers, they flow on a fluvial floodplain, right? So the every season the cross section changes, but in Lung Te Pho the cross section may not. There could be slight changes, that is acceptable, but the major changes won't have major changes may not be observed in Lung Te Pho, because it is permanent section, right? And moreover, the bed is not fluvial, it's it is a rocky bed, so it will not get eroded, or there won't be any deposition in a very short span of time. So we call that as the permanent control. What happens there is, once you develop the rating curve, this rating curve may not change. Now if you consider this scenario for southern Bhutan rivers, then the cross section heavily undergoes changes. So what happens is, the rating curve that initially you have developed will not work. So that is what we call by shifting control. So now control is getting shifted, because we know that discharge also the area of the cross section also affects the discharge, of course, right? So once area is changing, then everything else changes. So because of this, the control has now shifted. So that is the main meaning of the permanent and the shifting controls. Okay, now as an example, you can see this is the rating curve developed by initially it was known as Hydromet Services. Now we call it National Center for Hydrology and Meteorology, NCHM. Okay, initially it was Hydromet Services. So these people, they do hydrometry, so they are the responsible for doing the hydrometry stuff. So they have plotted the rating curve. As you can see, the values, some or most of the values are following the line, but some values are less, some values are more, right? This is because, as I said, the control, there is a slight shift of controls, right? So the controls are changing over time. Because of this, there is some changes. So but we have to fit the best fit line, and that is what we call by the rating curve. Now once this rating curve is established for a particular section, for example Lung Te Pho, and the gauging station number is ID is this much. So once this is established, now the next thing is, if we go right now to the river and measure the depth, and let's say that it is 2 meters. Okay, so if it is 2 meters, we can immediately tell that discharge at that section is 100. So that is the advantage of developing a rating curve. Okay, it works best for the rivers in the northern Bhutan, because it is not fluvial, but for southern Bhutan this approach is a problematic. It is a problematic approach, because every season the cross section undergoes heavy changes. So with this, let's continue. Okay, so this is the working of a rating curve. So first we do the stage measurement, right? So you can see here a stage hydrograph is plotted. So stage hydrograph, normally a person is employed, or you can use automated gauging stations, like automatic gauge reading. Some equipments is available, as I have also explained, right? The Stirling whale concept, the floats. And once we have the stage hydrograph and stage discharge, this is what you call by rating curve. So once you have the rating curve, then you simply take this value, and then you can find the value of Q. So likewise, we can have the complete hydrograph, which we call it as discharge hydrograph, and only the value of the hydrograph that shows the stage value is known as stage hydrograph. Okay, so to convert stage hydrograph to discharge hydrograph, we need a rating curve. So this is how these people are able to give us the discharge value at certain frequency of time. For example, today if the discharge is, let's say, at 10 a.m., if the depth is 1 meter, then so much of discharge. At 11 a.m., if the depth is again 1.5, then corresponding discharge value can be calculated. So that's the advantage of having a rating curve. Now comes the interesting part, that we now are interested to find the equation, equation of this curve from our observed data set. So how do we find an equation? So if we can relate, this equation is of course is going to be a function of stage, right? So what is the equation? So that finding that equation is our next part. So a major resistance and river, especially non-alluvial rivers, exhibit permanent control, like I explained, right? That does not undergo heavy changes. So these are known as the, if it undergoes heavy changes, then we call the shifting control. If it is not undergoing, then it is the permanent control. And if it is having a permanent control, then discharge can be related to the stage in the form of this equation, where G is the stage, A is the gauge value where there is zero discharge, and raised to power beta. So this is the equation, this equation represents this curve. So any rating curve can be elegantly represented in this form, and yes, so where this CR and beta are the model parameters or the curve parameters. A is the, we call it zero gauge, right? So zero, this is the height which represents the zero discharge. So this is the stage which represents the zero discharge. Now, how to find the values of this CR and beta? So that is what we have to discuss here. So our main equation is, as I have already shown you, CR G minus alpha A raised to beta. So now we can take the logarithm on both sides. So we'll have Q is equal to log of CR plus beta log of G minus A. So here we have the equation which is in the form of Y is equal to, so mx plus c, where Y, the dependent variable, is log Q, beta is the slope, right, and c, the intercept c, is log of CR, and the variable, the independent variable, is the log of G minus A. Log of G minus A, this is the independent variable. So if you plot a graph between log Q and log of G minus A, if you plot a graph between this, you should get a straight line, because this equation is in the form of an equation of a straight line. So that is what it means. Now same thing has been discussed when we have discussed the infiltration models, right? So here that time what we discuss is, what we have discussed is the graphical method, right? One is the graphical method, and second one is we have discussed the the well, it is also a graphical method, but I did not plot the graph, but I have directly used the value from the table. So let me call this as a table. It may not even have a name, but I'm simply saying that I use the table to calculate the slope and the intercept values, right? It was kind of a it is a graphical method only. I use, instead of directly plotting the values, I simply extracted the value of the tables, and then I have given you the shown you how to calculate the parameter. Now this time we are going to discuss about analytical approach to estimate the model parameters, that is the intercept CR and the slope beta. So we be using a method known as regression analysis. Okay, so we'll be discussing this method in the next slide. So okay, so right now I will stop it here for now, and I'll continue next.